Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Today we want to cover on chapter 6, modeling computation. So in this chapter we will go on three different subsections: language and grammar, finite state machine with output, and finite state machine without output. So for lesson today we just focus on 6.1, which is language and grammar. So in this topic, okay, the one in this topic, we just cover on grammar and finite state machine. The Turing machine is not covered in our syllabus. So the lesson outcome that we need to achieve today is we need to understand the language and grammar in models of computation, and then construct derivation tree. So you need to recall back what is tree in the previous chapter. So can you recall back what is tree? Tree is actually undirected graph with no simple circuit. Now the one that we always use as a language to speak is we call as a natural language. But in this chapter we will learn about formal language. Okay. The basic terminologies that you need to know is vocabulary or alphabet, words or sentence, empty or null string, and a language. So what is a vocabulary? Vocabulary is actually a finite non-empty set of element called symbol. So it can be the alphabet of ABC, either small letter or capital letter, or it can be any symbol to represent vocabulary. So this is just one example of vocabulary. Okay. So what is a word or sentence over V? V, we know V is a vocabulary. It's actually word is a string, mean a sequence of character from vocabulary of finite length of element of B. So for example, you combine you have a vocabulary as this one, you can combine any vocabulary here to form a word. So you can have A, B, A, you can have A, B, C, C, and many more. The empty or null string we denote with lambda. Okay, the string with no symbol. What is V star? V star is the set of all words over V. So it can be finite or it can be infinite. Okay, so this one is just one example of word. Usually the word that we get is from the rule, okay, from the grammar, but this one it can generate any word, okay, mean a collection of word from the vocabulary. A language over V is a subset of V star. So this one is an infinite. So V is mean it's restricted to some rule. For example, we just choose CAB, the small letter CAB, as a subset of this one. Okay. So now we want to know what is the page structure grammar. So a page structure grammar need to contain V, T, S, P. So what is V? V is vocabulary. What is T? T is a terminal, mean your end vocabulary, usually representing by the small letter. What is S? Is a starting symbol. What is P? P is a production. Okay, so whatever language generated by this grammar, it will based on this production, and we will start from S. Okay, so this one, if you see, a pre-structured grammar need to have 4 items. Okay, V, T, S, V. So this is your V, this is your terminal, usually denoted by the small letter. Okay, and then S is your starting symbol, and this is the example of production. This means the arrow mean S going to capital A, capital B, A. A will going to capital B, capital B. The one that is not in a small letter, which is in a capital letter, is not a terminal, mean non-terminal symbol. So our aim actually will base or start on S, and we need to ensure at last all the word in a small letter which is in your terminal. So you see, whatever we need to go to the terminal, all must be in a small letter of A or B. It depends on the question. So now we want to know how to find a language generated by grammar, because previously we know that grammar have their structure VTSP. Now we need to find the language generated by this grammar. For example, here you have V as a small letter A, small letter B, capital A and capital S. Your terminal, you see small letter AB, means our aim, actually we will start from S and we need to ensure all the language generated will be formed as a word that consists of a small letter of A and small letter of B. Okay, now the production rule that you have is S going to small letter A, capital A, S going to the small letter B, A going to the small letter of A and A. So we want to find the language generated by this grammar, or we denoted by L in bracket G. So you see here S is going to AA and you have S going to B. So means we need to do for both. Since the second one, S just going direct to B, is already terminal, so we just stop. And we know that one language that generated by this grammar is B. And then we start from here, S going to AA. And then you know that A is a non-terminal. So you need to substitute A with the production given in the question. So since we just have one choice, so I just substitute with AA. So since all in a terminal, so means we already finished. So we cannot generate any language other than B and triple A. So the answer as a language generated by this grammar is B, AAA. Okay, this example is finite language generated by this grammar. How about, or what happened if we ask you to find the language generated by this grammar if I added another one rule here, where A going to the capital A as one of the production. So we see the solution. Okay, so I add another one production rule in the previous example. Okay, so previously we know that S going to B, S going to AA, that you got AA. And here again, if I substitute A, this A, no more longer just AA, because I have another choices. I can choose AA. Okay, AA. So this A I substitute with AA. So AA, and then this A I just substitute with AA, this A. Okay, so you got the 4A. And then I do AA, this A again AA, and then this A again I substitute with AA again, AA. So I have the 5A. Okay, so actually we do this 3 times to ensure that we got the right pattern. You see that it has 3, 4, 5, mean A to the power of n. This power means it's not a power, but it's belong to how many A it's repeated. So for example here you put 3, means A is repeated 3 times. So the language generated by this grammar no more longer B, AAA, but it the final answer should be B, A power of n, where n start from 3, 4, 5 until n, because this one is in infinite. Okay, so to ensure your answer in good for the language generated by this grammar for infinite language generated by grammar, so please ensure that you do at least 3 times to ensure to see the pattern before you make a conclusion. Okay, so as your exercise, please ensure that you do all these 3 exercises, or you can choose one to upload in your Google form. Okay, next we go to the types of grammar. So in type of grammar, we just focus on the contact-free grammar, where every production is on the form A going to beta, where the left side is non-terminal. Okay, so we just focus on type 2 only for this course. So before we want to try for 3, to do a derivation 3, you need to recall back what is root, what is internal vertices, and what is left. Okay, internal vertices is the one that have a children, right? So it represents as a non-terminal symbol. Non-terminal symbol usually we use by the capital letter. Root is the starting symbol, so as. Leaf is represent the terminal symbol, mean usually we denote with a small letter. Okay, so now I have one example. Okay, the word W, this is one word, CBAB, mean this one is one word generated by this grammar. Okay, it's just one word. Okay, you need to recall back alphabet, word. Okay, this is just one word. Belongs to the language generated by the grammar of this one, where your V is given by this T, your terminal is ABC, and your production rule is given by this line. It asks you to construct the derivation tree for W. It asks you to construct this derivation of W. So our aim now is we need to know how we got the word the CBAB from the starting symbol S. Okay, because from there we can construct our derivation tree. So you see that the word that we want is CBAB, and we need to start with S going to the capital A, B, and we have a choices of A, B, and C. Okay, now you see here, this is our aim, CBAB, and this is given from the question. So as a solution, we need to start from starting symbol AB, and I know that my aim is to get the CBAB, so I need to choose the right one production rule to ensure that at last I can get the word CBAB. Okay, now I substitute A with capital C A, so capital C A, and then again, since I see that I want to have a C, and there is a choices here, either I choose B, either I choose CB. Of course I need to choose CB because our aim to have a CB as the first and second alphabet. So I substitute C with CB, small letter of CB, and then follow it, and then B, and I know that I want to have a B. So the right one is I choose this production rule of B, where I substitute the B with B. So this is meets our aim. Okay, so how we construct the derivation tree? Since you know here S going to AB, so S as a root going to AB. Okay, now you substitute A, right? The one that I underlined. So you substitute A with CA. So capital C, small letter of A. And then again, I underline C, mean I substitute C with CB. So under C, we have C and B. And B here, mean B here, I substitute with small letter of B. So I know that this is my derivation is 3 is correct when I see the leaf for all give you the word which is our aim, CBAB. Okay, CBAB. That is how we verify that our answer is true. Okay, so to ensure that you understand this chapter or this subsection, okay, please ensure that you do one of these questions, either question 4 or question 5. Question 5 is actually the same thing as what we have in the example, just it change the notation. Actually this notation mean double dot equal mean the arrow symbol, mean expression can go into digit, expression can go into expression can go into positive expression, until the last one you have operator can goes to the power. So mean this is Beckendorf form, so you need to transform first to this kind of production rule to ensure that you can do easily. Okay, for the question 5, okay, this is actually you have two different questions. This is the first question, this is your second question. Okay, so please ensure that sorry, this is actually the same question. It should be like this. Okay, it asks you to construct a derivation tree. This is two different questions. One question and this one is another one question, but you need to use the production rule given here. Okay, so that's all for today. Thank you. Hope so you understand this kind of topic.